Water is Africa's most precious resource. It is vital to conserve it, and it must be done in a manner that ensures effective distribution. The Vaal River Pipeline project is a prime example of how conservation and distribution can be managed efficiently. Using the best practice methodologies that have put South Africa at the forefront of global water management, the supply of one critical resource has been used to drive the insatiable demand for energy. The Vaal River Eastern Subsystem Augmentation Project was approved by government on 6 October 2004 as an emergency project, and TCTA was directed on 26 November 2004 by the Minister of Water Affairs and Forestry to fund and implement the project. The Vaal River Pipeline project was identified as the preferred project to augment the growing water demands of Eskom and Sasol in the Mpumalanga region. The increase in Sasol's Secunda plants and the recommissioning of numerous decommissioned Eskom power stations have increased the demand for raw water in that area. The existing water supply to Eskom and Sasol is from the Vaal River Eastern Subsystem, Vresap, where water is pumped from Grootdried Dam to Noppiesfontein diversion structure. At the diversion structure, water can be discharged into the Grootfontein or Bosjesspruit dams, from where Eskom and Sasol respectively abstract their water. The Vaal River Pipeline project will augment the Vresap by transferring water over 115 kilometers from the Vaal Dam to the Noppiesfontein diversion structure. The Vaal River Pipeline will increase the existing Vresap yield of 301 million cubic meters by 160 million cubic meters of water a year. A typical Eskom power station consumes millions of liters of water per day in a wet cooling process, so the impact of any water shortage will be catastrophic. Similarly, the case with Sasol, which requires continuous water supply. The current cost estimates put the cost of the project at 2.7 billion, with the loan capital being fully repaid by the year 2028. The project will transfer water from the Vaal Dam, where a new intake structure is under construction about 5 kilometers from Vaal Marina. The water will be pumped 115 kilometers to the existing Noppiesfontein diversion structure that will be enlarged to accommodate the additional water from the Vaal River Pipeline project.
Water supply is one of the critical elements to support the Synfuels operation. The Vresap project is of significance to Sasol in that it enables the future growth of the facility, enables us to manufacture more fuel in future. It also mitigates against the risk of water shortages during drought conditions.
We are also pleased with the fact that from a governance perspective, the stakeholders have been represented in the decision-making process. So it has actually enhanced the project management as well as the contract strategy of the project by enabling stakeholders to have input into the decision-making and also ensuring sound governance.
And it's provided substantial job opportunities. There's been also a major BEE component of this project that has ensured that significant job opportunities are provided in terms of this particular project.
The primary elements of the project include abstraction works located immediately downstream of a channel to be dug within Vaal Dam, 2 sets of 3 low-lift pump units that will draw water from the intake and pump it through an 800 meters long pipeline into 3 balancing dams where silt is allowed to settle, removing coarse material that can damage the pump propellers. From the balancing dams, the water is led into a series of high-lift pumps, each with its own booster pump. Booster pumps are provided to create allowable suction pressure for perfect performance of the high-lift pumping system. A surge tank was constructed at the highest point along the pipeline route. The surge tank is a 10,000 cubic meter reservoir that provides protection against damage in the pipeline system caused by high pressures generated within the pipeline from sudden opening or closure of valves or unplanned pump stoppages. The surge tank will always be filled with water, and when negative pressures occur within the pipeline, water will be automatically released to fill the vacuum in the pipeline caused by the negative pressures. The pipeline runs largely through agricultural land and is buried between 1.2 meters and 7 meters deep, depending on the terrain. Pipe jacking was used where the pipeline crosses existing national infrastructure such as roads and railroads. where the pipeline traverses rivers and streams and in close proximity of settlements or homesteads, special measures were taken to minimize social and environmental impacts. The importance of consultative approach to project governance has been ensured by TCTA via institutional structures that focus on stakeholder participation. The governance structures are embodied in the agreements signed by the parties. The first agreement, the Water Supply Agreements, set out the terms and conditions of supply from the Department of Water Affairs and Forestry to the main users, Eskom and Sasol. The second agreement, the Implementation Agreement between the Department of Water Affairs and Forestry and TCTA, tables the terms and conditions in respect of the project implementation and the payment by DWAF to TCTA for delivery of raw water. In March 2006, the first sword was turned to mark the commencement of the project. Val Pipeline Consultants, a consortium of consulting engineers, was appointed to do the design and construction supervision of the project. The Department of Water Affairs and Forestry was appointed for the mechanical and electrical engineering design of the project. Two main contractors were appointed to construct the Vaal River Pipeline project. The contractor appointed for the supply and installation of the pipeline is Mpumalanga Pipeline Contractors Joint Venture MPC, who successfully bid for the 1.39 billion contract. A second construction contract was awarded to Covec MC Joint Venture in November 2005 for the construction of the civil works, the supply and installation of the mechanical and electrical components, and the value of this contract is 417.9 million rands. Early on during the construction, the excavations for the permanent abstraction works revealed geological conditions very different from those foreseen during the tender stage. This required amendments to the design of the abstraction works and the associated coffer dam. To ensure minimum delay to the delivery of water to Eskom and Sasol due to the delay in the construction of the permanent abstraction works, an additional contract was awarded to construct a temporary abstraction works. This temporary floating structure was designed to deliver the full capacity of the project until the permanent structure is complete. A number of social and environmental challenges had to be overcome on the project, such as the timeous acquisition of land rights, the removal of graves and reburial from the pipeline servitude, rescue, safekeeping, and replanting of endangered plants after the construction works.
Most of the environmental management was focusing on the monitoring of the impacts of construction activities on the surrounding environment.
Vresap lilethe umehluko omkhulu kumphakathi wakithi, akuzuzanga nje laba abaqashwa yiyo, kodwa nosomabhizinisi nabo bazuzile kule project.
I also believe that innovation played a role in mitigating the environmental impacts at the abstraction works. We had to come up with innovative ideas in our design to basically optimize or reduce the footprint of the abstraction works.
In addition, technical challenges requiring innovative solutions such as the manufacturing and transportation of the 1.9 diameter by 18 meters long steel pipes, the use of a barge for underwater drilling, transportation of the excavated material, and the design and construction and later removal of the temporary coffer dam were faced.
TCTA learned many lessons on the implementation of the Vresap project. These lessons we are going to institutionalize and make sure that we learn from those experiences in the implementation of our new mandates.
The project is a remarkable engineering enterprise that implements innovative fiscal management with high-level technical operations. It illustrates that resource control, if managed effectively, can strike the balance between supply and demand.